Good morning, and welcome to INSA's Coffee and Conversation with Gil Herrera, the Director of Research at NSA. Our program will begin shortly, but first, a video from our sponsor, SAIC. Apologies for the delay. I'd like to now welcome INSA's Executive Vice President, John Doyon.
Good morning, and thank you for joining us for Coffee and Conversation. This morning, we're pleased to welcome one of our community's top leaders to our program. Before we begin, a couple of the usual housekeeping notes. If you have questions, and we hope you do, please submit them through the questions box on the right side of your screen. We'll do our best to get to all of your questions. We're pleased to welcome members of the press to the call today, and so this is a reminder that this program is on the record. And finally, I'd like to thank our program sponsor, SAIC, for their support of today's program. And it's my pleasure to welcome Charlie Salvaggio, Account Executive for SAIC's National Intelligence Community Business Unit and a retired NSA Senior Executive, who will introduce our speaker. Charlie, over to you.
Thank you, John. On behalf of SAIC, I would like to thank INSA for holding today's discussion. In today's ever-changing national security environment, simply keeping up with the threats isn't good enough. At SAIC, we're proud to be an industry leader in harnessing the power of artificial intelligence, machine learning, and data science to deliver proactive insights to NSA, the broader intelligence community, and beyond. SAIC recognizes the challenges faced by the IC in meeting evolving threats, and we're committed to delivering solutions that meet those needs. Now, it gives me great pleasure to introduce our speaker. Gilbert Herrera serves as Director of Research at the National Security Agency. The Research Directorate conducts world-class scientific research to deliver new and innovative techniques and technologies to enable the signals intelligence and cybersecurity missions of NSA and the Central Security Service, as well as joint authority missions of the intelligence community and the Department of Defense. Mr. Herrera joined NSA after serving nearly 40 years at the Sandia National Laboratories, where his last assignment was a laboratory fellow, only one of 15 such appointments in Sandia's 70-year history. In 2020, he was appointed to the U.S. National Quantum Initiative Advisory Committee, which advises the nation's senior decision makers on matters concerning quantum information science. He is a fellow of the American Association of the Advancement of Science and a senior member of the Institute of Electrical and Electronics Engineers. Please welcome Gil Herrera.
Thank you, Charles, for the great introduction, and I look forward to having some coffee and having a conversation.
John? Exactly. I'll hold up my mug too. We'll get you one of these if you want an INSA mug. But thank you for joining us today as well. And we were talking just before we got started. You're right at your 1-year anniversary at NSA in the position as the Director of Research. And so that's a great place to start the conversation. Can you tell us about, a little bit about your role and especially what your priorities you have coming to this job after your long career at Sandia, the priorities you brought to the directorate, and some of the big challenges you're hoping to tackle in this job?
Yeah, certainly. Yeah, it was an interesting transition, working at a national lab, and I had spent a little bit of time in industry during my career, but coming in at the end of the career is a very different experience. So what would motivate me? Well, one of the reasons that motivated me was, I'd been working with NSA to a certain extent over the prior 20 years. If I go back to most of my time at Sandia was involved in microelectronics and semiconductor research. And we had partnerships with NSA primarily in things like utilizing techniques we had developed for the semiconductor industry to do failure analysis and applying those to reverse engineering, for example. And that work extended back into the 1990s. But when I became director of MESA, so director of the semiconductor and microelectronics research in the mid '00s, then I really started a strong relationship with NSA. Invited Ben Cole, who was the technical director of research, to serve on our advisory committee, and then started doing a lot of collaborative work with them, to the point that in 2015, NSA asked me to come on an IPA, and so I was on loan from Sandia to be the director of physical sciences research at NSA and the director of LPS. So after returning to the national labs and having the easiest job I ever had as a fellow, I decided a year ago to give up that easy life and come and serve the nation. I'd always wanted to end my career in direct service to the nation, and it was a good opportunity. But in terms of priorities, when I came here, basically the message that I brought to the director and the deputy director and executive director was really 4 key themes. One is that, and these were in part based on observations I made when I was part of the research team running physical sciences research, that NSA really was one of the last bastions within the government where there was a large intramural research program. At the end of the Cold War, many government agencies, kind of gave up the expense, when faced with large budget cuts, the expense of a large intramural research program, and they went to a lot of effectively contracting, both with industry, but also with national labs and with universities. In fact, as a Sandian, I was a beneficiary of that, in that we had very, very large research programs with the intelligence community and the Department of Defense, among other agencies. So, but NSA maintained a core research organization, and one of the motivations was a commitment to come and sustain that. And when you have a large intramural research program within a mission agency, then you really need to focus on mission problems, while you're simultaneously trying to balance a portfolio of near-term, intermediate-term, and especially maintaining a long-term research agenda so you can envision future priorities. So that's one, is keeping the strong intramural research program that is mission-focused, but has a balance of research. Then, of course, because we're a mission organization, finding ways to more effectively transition that technology into mission application. And there were a number of observations I made of some parts of NSA that was research that was doing it really well. The quintessential example of that is math research, and then others that maybe could do a better job. The next challenge, and it's one that we also faced at Sandia, is the technological landscape is changing really rapidly. And how do we keep up with those advances? Gone are the days when the government drove a lot of those advances. We still fund a lot of the basic research, but the internet is changing. The various G's used for cellular are changing rapidly. Then how do you maintain the subject matter expertise to enable NSA and the broad intelligence community to keep up? So that's a third element. And then the last one, of course, deals with something that I know that every INSA member struggles with, and that's how do you hire people? Getting people hired that are clearable and that have the relevant skills, and with all the constraints we have, competing with companies that pay more money and give on-site job offers, is a challenge. And so, you really got to sell the mission. You got to sell the ability to, have access to some of the best tools, and other aspects, are critical for us to get the workforce that we need. And those are kind of the 4 things that I sold. A strong, balanced intramural research program that was dedicated to tech transfer, that kept up with the latest technologies, and were able to track a strong workforce. And those are really the things that I'm trying to bring to my role as director of research.
Great. One thing you said that started getting me thinking, you mentioned focusing on mission priorities in the research directorate. And I know that you're the research director looks across all of NSA's mission set. And so I wanted to take a little pause and look at NSA's SIGINT mission right now and ask you, from your research chair, what are the advancements in technology? You mentioned mathematics as well, and science. What advancements have there been that are really critical to the SIGINT mission area, and how are you applying those at NSA and working through those?
Yeah, I was thinking about this question because it's one that is exceptionally difficult to answer in this environment. So let me speak more to kind of how we're organized and how we keep up with the key focus areas. So when I describe the research organization, I think of it kind of like a small university, that has a math department, and quite frankly, it's the best damn math department in the world. And we partner with the almost best math department in the UK and other exceptional math departments around the world. And we have a reputation that allows us to hire from universities and relationships with academics and cleared academics that come and help us out in the summers. We manage the Institutes for Defense Analysis, 3 FFRDCs that are an integral part of our team. And so, we're able to maintain a strong math department in all the requisite fields. And as we move to a post-quantum environment, the types of mathematics we need even expands, greater beyond kind of traditional linear algebras and statistics and whatnot. So we also have a cybersecurity department. Yeah, R1 is our math department. R2, and there we're engaged in a strong cybersecurity portfolio. Big challenges now that pretty much everybody's going to the cloud, and now that we have emerging virtualized environments. 5G is effectively a virtualized environment, and future communication backbones are going to be like that. So a good cyber department. R3, strong physics department. While we're known a lot for our work in quantum, it goes well beyond quantum, and a strong portfolio in beyond CMOS and beyond von Neumann, beyond CMOS devices on one end and beyond von Neumann architectures on the others, that we could explore in more detail later if you want. And also understanding the physics of signals intelligence, right? How signals are propagated, and understanding how to work in that environment. R4 is effectively our electrical engineering department, and works in primarily in how you can detect and use those signals for our signals intelligent and collection missions. And then R6 is our computer science department, and there's a strong focus there on AI ML, on developing apps for the analysts so they can best do their job. And also data analytics. There's an adjunct that they have, the Laboratory for Analytical Sciences, that's at North Carolina State University, that has a special emphasis on big data analytics for operational uses. And that's pretty much the way we're organized. But in terms of focus areas, trustworthy, secure, and compliant AI and ML. I've been in the IC for just over a year, and I understand that compliance doesn't mean compliance with environmental safety and standards. That compliance really means, living by US laws, and that's something that's integral to everything we do. So, and it makes it particularly difficult when you think about doing AI ML algorithms, how you comply with those. So that's why I put that on par with kind of the dependable and trustworthy part. A strong focused area in there. Cyber defenses need to be automated, to be able to respond with a number of threats that occur. Hardly a millisecond goes by where there isn't some kind of a probe that's, launched across the world. And so having automated cyber defenses, deep fakes and maligned influences are areas of focus for us. how do we understand and mitigate? And we've got elections coming up, so we're very worried about election security in that context. I already mentioned about security in virtualized and cloud environments. It's no longer can we build a fort with a moat. We don't even know where our fort is, right, in the cloud, and so we need to worry about that. And again, I mentioned about emerging device and computing technologies that are kind of classical in nature, and then of course going to quantum and what quantum is going to look like.
Great. Hey, a lot there to talk about. And I know this is an area of your expertise. You have a number of areas of expertise. Let's jump to quantum and quantum computing. Earlier this spring, the president signed a national security memo on quantum computing. He laid out a whole host of actions and for the government to take. What is NSA's responsibility in this area, and in particular, what's NSA doing to mitigate risk to vulnerable cryptographic systems and participate in the mandate to implement post-quantum cryptography? You talked a little bit about that. Can you tell us where's NSA as far as helping keep our nations secure, looking at the eventually here the advent of quantum computing?
Yeah, let me start with a little bit of history, and then I'll save the thunder for the end, because I'm going to tell you what to Google, because we're just about to issue a national security guidance for how to comply with the recent presidential directives. I was hoping it was going to be available for me to announce at this meeting, but it should be by Friday. We'll be announcing some level of guidance. But let me go back and talk about history, right? So Peter Shor published a paper just about 27 years ago, and in attendance at the conference where he presented the paper were NSA scientists who within 8 months established the first quantum computing research program in government, and that's been a continuous program. In fact, NSA has been the largest sponsor of unclassified quantum computing research. I can make that statement. I think it's still valid today. The Department of Energy may have overtaken NSA. Of course, I can't say what the number is because all of our budgets are classified, even for unclassified research, but major programs. And so over the history of quantum computing, the work that led to the Nobel Prize that Dave Wineland got, NSA was a co-sponsor of that work conducted by NIST. The development of the Transmon qubit, which has received every award short of the Nobel Prize out of Yale University by Shulkoff's group, was also funded by NSA. And the Transmon is the one that most superconducting-based quantum computing programs and companies use. And so long history of that. And why do we do that? Because if we don't understand where the technology is, then we can't understand how big the threat is. And maybe not as soon as we developed a program in quantum computing, but within a couple of years, it was still last millennium, the late 1990s. NSA math research started to envision, what is a post-quantum, cryptographic landscape going to look like? And algorithmic work started by the year 2000. NSA was already exploring what's it going to look like, what's the capability of Shor, are potentially there other algorithms, for these, very difficult, one-way problems upon which most cryptography is based. And so we actually started developing algorithms and had, by 2015, algorithms worthy of protecting key national security systems. So this is something we've been preparing for, for a long time. We just don't know when the right time is to launch them. And while I'm probably more skeptical than most about when we'll actually have a cryptanalytically relevant quantum computer, it could happen within the next, as the best definition of I've heard is anywhere from 10 years to never. But we are starting to get in a window of concern. And, the White House, of course, has issued strong guidance and strong warnings to tell people to start that journey, because it's going to be a big lift, right? The prime factors is a really optimal and easy problem to reverse out. And some of these other post-quantum methods are going to be a little bit more challenging in terms of, particularly when you look at the amount of energy it'll take on edge devices like iPhones. I pull one out of my pocket, but if I have one here, I'd be walked out. But edge devices and things of that sort, and even think about your Ring cameras, that you're relying on this little trickle charger worthy of operating a doorbell, is now going to have to potentially have algorithms that are going to have a lot greater energy utilization. So it's going to be a big lift to go to post-quantum, and that's why we're warning now. So, NIST is responsible for protecting and advising on commercial systems, and they've done a great job, with their first rollout that happened a couple of months ago. They actually were, to my recollection, about a year in advance what the deadline was. And so they don't have a complete rollout. And I think within the next year, they'll have a few more standards, particularly related to signatures. What NSA will be rolling out, hopefully later this week, will be guidance for the defense industrial base. So all the INSA members to follow relative to post-quantum cryptography. And I've already reviewed the guidance. It's like 10 or 11 pages, covers every contingency that you'd want to do. So I would encourage you, for those of you that are online, after the meeting, to go ahead and just Google NSA post-quantum cryptography and maybe put a 1-week time window on it, and eventually you'll see it come out. There should be a press release also, but there's very specific guidance that talks about the nature of algorithms. There'll be strong recommendations on, which NIST algorithms would likely be the best national security solutions. There'll probably be guidance on quantum key distribution, which NSA is not advising be utilized for national security systems, among others. So that's kind of the best approach, is Google that. And again, I apologize for not being able to announce that today. I was hoping I could, but it really is imminent and should be out tomorrow.
Nice. Well, it's making me think next week, George Barnes will participate in the Intel Summit on a panel with all the directors, and maybe he'll have a chance to talk about this new guidance coming out at the end of next week for that big event we're going to be having. But so you're saying 10 years or so is still, I've been hearing quantum computing's 10 years out for the last 20 years.
Well, I'm actually not saying it's 10 years out. That is a window where if everything goes perfectly, then there's enough of a likelihood that there could be a sufficiently large system that we're really worried about making sure that our financial systems are protected. With the national security community, we have a different problem, right? I think about my background at Sandia. There are still vacuum tubes in the nuclear stockpile, I believe. So these systems last a long time. And so design information for things like nuclear weapons, and we're going through a big uplift with nuclear weapons. How old is a B-52 bomber, right? And, now most of the internal systems have been upgraded, but we have systems that are deployed for very long periods of time. And so, we've been sending that design information encrypted, conceivably using things like RSA, although hopefully, it had a AES shell over it. But there are information that have very long lifetimes. And so that's why it's particularly important for the INSA community, to worry about quantum resistant cryptography. If you were to ask me personally, I think it's probably more like a 30-year. That sounds more like I'm talking about fusion energy, but it really is far off. And the reason why I say that is and again, I have a strong background in semiconductors. The reason why we were able to scale semiconductors is we had a really strong theoretical basis that, you know, dumb engineers like me could understand, right? You know, we had semiconductor device physics. The book I grew up on was SZE, first published in '68, I think updated in 2012. But as we advanced through Moore's law, you know, we were able to model predicted solutions. And there was a huge evolution. If you look at what microelectronics were when it first came out, it effectively used 4 materials. Now there's like 60 materials used. But on each step where we had an advancement, you know, introduction of high-K and low-K materials, going from aluminum to copper, introduction of tungsten, strange lithography, going to 3D structures like the FinFET, then we could model the devices, and we knew as long as we could manufacture what was modeled, that they would work. We don't have that corollary with quantum computing. That's why you hear about ion traps, and you hear about superconducting and semiconducting and neutral atom and different kinds of photonics approaches, but not one of them has a theory that couples manufacturing to model devices. I get into this argument all the time with a physicist, since I'm an electrical engineer. The corollary of quantum mechanics to semiconductors is actually Boolean algebra, right? Because the reason why you get the speed up in quantum computing is because instead of dealing only with 1 and zeros, you know, you're dealing with, I'll make the mistake I hate, but I'll say it anyway, with something that's both a 1 and a 0. A lot more complicated than that, right? You know, it's a probability wave function in Gilbert space, and that's what makes making a quantum computer so difficult, because that's what creates so much of the problems with noise in quantum computers. But that's what the corollary is. And then to make a microelectronics device, you have device physics, you know, which is the interpretation of quantum mechanics, because microelectronics is a quantum mechanical device, and that engineers can use with these tables and properties of materials and understanding the capabilities of tools, and you can model what you're going to make. And we don't have that with quantum computers. And that's why it is so difficult to predict when we'll have a quantum computer, because there's not a strong enough underlying theoretical basis for how the devices actually work. And that's why I don't believe anybody's predictions on quantum computing, even mine. But if somebody were able to make one, our national security systems and financial systems are at jeopardy. And that's why the White House and NSA are warning people to go to quantum resistance.
Yeah. Hey, thanks for all of that. Let's change the subject back to something else you talked a little bit about, which is innovation. And you said that's a key area for you. And if you talked a little bit about where IC agencies and the Defense Department, for example, back decades ago, innovation happened. All the cutting edge stuff was in classified programs that was done by the government. Today, we see innovation being done private sector, out in Silicon Valley and other parts of the country. How does this, how is NSA taking advantage of the innovation that's being done elsewhere? How are you addressing innovation within the at NSA? And you talked about the little, still a really strong intramural research organization. How do you get all that innovation and then, and more importantly, transferred into the mission? Can you talk a little bit more about that?
Yeah, certainly. During the 1960s, the government created the semiconductor industry. I mean, it did so not just with NASA. I don't know, there were I think up to 20 Saturn rockets built, but there were thousands of Minutemen and Titan and Atlas and Poseidon and others. So I think during the 80s and 90s, the government still thought it could control industry and innovation with big contracts. And then they got woefully surprised, because private industry drives the underlying technological infrastructure that we ride on. That's just the reality. The reason why it's important for NSA to have a lot of subject matter experts is so we can best exploit and understand and utilize that backbone infrastructure. But we're not going to drive it, because we're not going to drive standards because the volumes are insufficient. So that is why it's even more critical for NSA and, quite frankly, all the intelligence community to embrace innovation as a part of the way they do business. And you know, we certainly support InQtel. You know, the Defense Innovation Unit is great, and those are tools that we need to leverage. But innovation kind of comes from within, and it's a type of thing that needs to be not an applicative side, but a part of how we do business. And so with that, the way we best exploit innovation is first fully understanding the commercial infrastructure, and then thinking about our own problems, and then leveraging that commercial infrastructure, maybe facilitated by technologies or tools or apps that we develop, to leverage that in the context of working with and supporting the tip of the spear, you know, which are the NSA and other agency analysts that actually perform the work. Now, what that means is that to really innovate in today's environment, it requires a whole team. You know, from the, you know, you have government that has certain unique needs, you know, industries providing, if you look at the broad big tech industry, they're kind of providing the standards and the ultimate technologies, particularly information technologies we ride on. You know, we have our partners in the defense industrial base that we work with to, you know, help deploy major systems. There's a role for national labs within this, you know, that kind of work on applied research, and then of course the universities that are doing the more fundamental research. And so we have to have that big team. You know, it's supported by organizations like InQtel that maybe help people from universities and national labs and people that want to lead big companies to start little companies that are a bit more agile. And so at NSA, what we have to do is to embrace that entire ecosystem, you know, to work with everybody from people doing kind of fundamental research in the universities to having strong relationships with big tech companies and the big players in the defense industrial base. And I view part of the role of NSA research as being part of all these communities and helping serve as kind of a lubricant, you know, something that can help let the best ideas win. And then by creating the internal partnerships within NSA, with our operational directorate and with our capabilities directorate, to help more rapidly get tools into the hands of the analysts. One of the, I think the big problems internal to organizations, you know, and I've been in research organizations most of my career, one of the biggest problems that researchers face in transitioning technology is they forget about the people in the middle of the value chain, you know, where they'll go directly from a researcher to somebody at the tip of the spear and talk with them about their needs and have an idea that is not compatible with, you know, like the corporate infrastructure they have to write on, and then they make the operator fall in love with the technology that they just can't have because it's not scalable. And so one thing I'm pushing is this notion of you have to have knowledge of technology throughout the value chain, and when it comes to internally to, in the case of NSA, that it's got to be a team that includes research and operations and capabilities, and more often than not, our engagement and policy, right? Because it's got to be compliant, and that you know, work these teams, because to really innovate, you have to have a big team and everybody's respected and valued.
Okay. Hey, we've got a number of questions coming in from our listeners, so thank you for that. And a handful of them are all related to engagement. So one is, how can industry partner with you better to co-develop technology via IRAD? Another talks about how do small businesses submit their innovative ideas to your organization. Another is, what's the best way for research in a that's going on in an industry to interact with research at NSA? Can you talk a little bit about industry engagement and the best way to do that? And then I also know that you do a lot of work with universities, and I think you wanted to give us a view into that as well.
Yeah, in addition to running the research organization, I also have our innovation group, but I also have the ORDA, and I'll say that term because most of you probably know it, but for those who don't, ORDA is a weird word, came up with in 1980 that really means Tech Transfer Office. And so also our intellectual property licensing and our CRADAs and other forms of agreements run through the research directorate. So let me start with that end in terms of industrial engagement, because there's a lot of ways to engage. On one end, that we do have about 125 pieces of IP patents that are available for licensing, and we do that work. But probably our biggest way of engaging directly in the context of intellectual property is open source. Things like Ghidra, which had 50,000 downloads when it was announced at our RSA. Ghidra is a software reverse engineering tool that is utilized in cybersecurity in order to help see if there are code implants in some of your codes. Cumulo, which is we actually we did an open source, but the Adobe Foundation created that into an open source product, and that's for managing data in the cloud in a secure manner. Healthcare industry utilizes Cumulo, as do the financial industry, right, because of this unique cloud security problem. And SD Linux, which is for those of you who are not Apple people, have Android phones, SE Linux is the operating system. And that's another example of how we work with industry, and is by making things open source, and then we support it, right? We do periodic updates. We go to conferences that are organized around that. But I think many of your particularly small businesses probably want to know about things like contracting, and we use conventional techniques. We do broad agency announcements. You can go to the NSA page and sign up for all of our public announcements for things like BAAs. Just go to nsa.gov and you'll look for a thing that talks about partnering and contracting, and go there. In the case of what I know the best, of course, and on the quantum side, we oftentimes work with other entities like the Army Research Office to issue BAAs, and you can find those at the NSA website, but you could also find them on the Army Research Office website. And so we advertise BAAs. And then we also have conventional RFIs and RFPs, and all those you could find about on the NSA website. But in terms of other, like a lot of research collaborations often get started where there's not so much a financial transfer, but there's a willingness of people to partner. And I got to be careful what I say, because I'm learning that there are a lot of rules that when you're a national lab, maybe you don't have to follow. And so I'm used to in a national lab of you meet an academic at a conference, you share emails, and you're already doing collaborative research, while you're on the airplane, where you put in $8 at Southwest and you're sharing proposed ideas. There might be a little bit more paperwork we have to do. They're relatively easy to do. I was at Vanderbilt University a couple of weeks ago. We already had a agreement in place, and they're simple agreements. They don't require financial transfers, but we are willing to work with any university out there, come one, come all. We already have hundreds of these agreements, so it's likely if you're at a university that we already have in place the agreements that permit us to engage in collaborations and discussions. But even without that, I'm personally willing to take any email member from any of your listeners. My email address is G as in Gilbert, V as in Victor, then HERRE at nsa.gov. I also have a .edu account gil.herrera@lps.umd.edu. And if you want to send me an email message, then I could likely get you in contact with the right kind of investigator, because, one of the other things that I'm trying to bring to NSA research is, this big boat concept, right? Where, we'll talk to anybody, I'll personally take a meeting with any company. I obviously we can't differentiate. One way to get around having to have contractual agreements in place is just agree to meet with everybody. And so if somebody contacts me, I'll have a conversation with them, or a Skype or a meeting. So I'm open to that. And I just shared my contact information. So we'll be happy to talk with you in greater detail.
Hey, I have time for maybe one more audience question here. But first, let me say another audience member wrote in and said NSA does have on its website posted now its release on the future quantum resistance requirements. So thank you for noting that. And but something we haven't talked much today is cybersecurity. We have a question from one of your colleagues, perhaps Kier Henderson over at Johns Hopkins APL. What do you see as the high priority research areas for cybersecurity in the next 7 to 10 years, so a longer view?
Yeah, it's something I alluded to earlier, but to me, the biggest challenge is it just comes at us too quickly, and we're going to have to automate. So coming up with dependable, reliable ways to do automated cybersecurity. I mentioned Ghidra. Ghidra requires an analyst to do reverse engineering. Great tool, but think about kind of an automated Ghidra. We're going to really need to push cybersecurity down to level 3 and below. Find ways to just not to let it get above the physical layers, right? Those to me are the biggest challenges. It's just too hard to do cybersecurity in the conventional way. Better ways that, how do we go to the left of 0 day? That's a big term used in DoD about left of the boom. How do we go to the left of the boom relative to 0 day? Those are the bigger areas. But if there are one thing I think is the highest priority area, it's finding ways to automate it. Hopefully machine learning will provide some usefulness there, but that's only part of it. When you go to cloud-based cybersecurity, I think some of the microelectronics vendors are starting to put in hardware hooks, and then how we best exploit those, because they're not fully exploited now, I think is another area of research. And I look forward to visiting APL on Monday.
Great. Well, we are just about out of time, but I'll turn the mic back over to you for any closing thoughts you might have this morning for us.
Well, first, thank you for the opportunity to talk with you. As I mentioned, I view part of my role in research as kind of building this, big ship, and that only works through meeting with partners. I gave you my contact information. Happy to talk to any INSA members, to any people at universities. Come big, come small. We're all in this together. We all have a commitment to the intelligence community and to national security systems, and I look forward to working with all of you to help secure our networks, help advance our defense and national security interests. And as I mentioned, send me messages with any questions, and I'll get back with you.
Great. Well, thank you so much for your insights and sharing with us today. If anybody wants to wasn't taking notes fast enough, we'll be posting a recording of our conversation on the INSA website later this week. So Gil, thank you again, and thanks to everyone who was able to join us today, and especially thank you to SAIC for supporting today's program. When the webinar ends, there will be a short survey that pops up, so we ask you please take a few moments to complete it and let us know how we did. And as I referenced during the discussion with Gil, next week we do hold our annual Intelligence and National Security Summit on the 15th and 16th of September, which is in person at the Gaylord Convention Center over at National Harbor. Each year we do this with AFCEA, and this year's program touches on a number of current issues, including Chinese threats to supply chains, the Russian-Ukraine conflict, midterm election security, and as I referenced, the panel with the six big directors of the intelligence community agencies. On September the 20th, my colleague, INSA President Suzanne Wilson-Heckenberg, will host CIA's Associate Deputy Director Julianne Galina for a virtual coffee and conversation focused on digital innovation across the CIA enterprise. And then later this month, INSA will head west for a two-part Common Threads program in Colorado. We kick things off on the Tuesday, the 27th at the Gaylord Rockies Resort with a networking reception and keynote remarks from Sandra Ochter, who's the director of NGA Denver. And then the next morning, we'll hold a classified panel at the TS-SITK level on cybersecurity of space systems. And that'll be at the Northrop Grumman SCIF in Aurora. We've got a great lineup that morning with experts from NRO, NSA, MITRE, and Northrop Grumman that'll discuss the cyber threats to national security space infrastructure and other related issues. And also would like to bring to your attention, we recently opened nominations for our 2023 Achievement Awards. These recognize outstanding early to mid-career professionals in the intelligence, homeland, and national security community. These awards are an excellent opportunity to honor rising stars within your organizations, as well as a leader who helps mentor and advance a diverse, talented workforce. And finally, especially for our colleagues in government tuned in today, I'd like to let you know that the INSA Foundation is now an approved combined federal campaign charity. So please consider selecting INSIF, INSF, when you make your CFC selections. Importantly, 100% of these funds raised through CFC will go to the scholarship program that we call the Future of the IC Workforce, that will help mission-driven undergraduate and graduate students pursue careers in service to our country. You can learn more at our website, insaonline.org. This concludes this morning's program. Have a great day.